Hello everyone, welcome to this class. Today we are going to talk about Introduction to Sets Part 4. Here we are going to discuss more on sets. So this is the outline for today's class. So first we will discuss about De Morgan's laws, then we will discuss about Cartesian product of sets, then we will discuss what are the further resources to prepare from, and finally we will have the conclusion. So let's look at what is De Morgan's laws. So if A and B are two subsets of the universal set, then the complement of the union of two sets is the intersection of their complements, and the complement of the intersection of two sets is the union of their complements. So these are known as De Morgan's laws. So we can write these laws in this particular way. So as you can see, the first equation says A union B complement is equal to A complement intersection B complement. Then we can also see that A intersection B complement is equal to A complement union B complement. So now let's look at an example. So here you can see that U is the universal set and it has the elements 1, 2, 3, 4 and 5. Now let's consider two sets. A, one has elements 1, 2, 3 and set B which has element 2, 3, 4. And from the Venn diagram, we can clearly see that set A and set B are the subsets of the universal set. Now let's consider what will be the A union B. So it will be 1, 2, 3, 4. Therefore, the complement of A union B, if we consider the universal set U, will be a set with element 5. Now, if we find out what is A complement intersection B complement, it will be set with element 5. So we can clearly see that in this case the A union B complement is equal to A complement intersection B complement. Now let's take a look at what is Cartesian product of sets. So given two non-empty sets P and Q, the Cartesian product P cross Q is the set of all ordered pairs. Please note the word ordered. So it's an all ordered pairs of elements from P and Q. That is, can write P Cartesian product Q is equal to a set of all ordered pairs P Q, where small p belongs to the capital P, the set P, and small q belongs to the set capital Q. Now let's look at an example. So if we consider set A with elements 1 and 2 and set B with elements small a, small b and small c, then the Cartesian product will be the set with the following ordered pairs. The ordered pairs will be 1a, 1b, 1c, 2a, 2b and 2c. So there are certain properties of the Cartesian product of sets. So let's look at them. So the first one is two ordered pairs are equal if and only if the corresponding first elements are equal and the second elements are also equal. The second property is if there are p elements in set capital A and q elements in set capital B, then there will be p into q elements in the Cartesian product of A and B. That means if NA is equal to p and NB is equal to q, where NA denotes the number of elements in A and NB denotes the number of elements in B, then the number of elements in the Cartesian product of A and B, that is NA Cartesian product B, will be equal to PQ. Also, if A and B are non-empty sets and either A or B is an infinite set, then the Cartesian product of A and B will also be infinite. Let's look at an example. Let's consider the set capital A with the elements 1, 2 and then set B with elements small a, small b and small c. Then if we find out the total number of elements in the Cartesian product of A and B will be equal to 6, as you can see here. Then you can see what is the number of elements, the cardinality of set A, which is equal to 2, and the number of elements in the set B, that means the cardinality of B will be equal to 3, and therefore the product of the number of elements in A and number of elements in B will be equal to 6. So you can clearly see that in this case, this is the cardinality property is satisfied. That means the number of elements in the Cartesian product of A and B is equal to the product of number of elements in A and the number of elements in the set B. So further resources about sets are available in the NCERT class 11 mathematics textbook, in particular in chapter 1.10. So this lecture basically concludes our discussion on sets. So to conclude, we can say that the foundation of mathematics, to understand the foundation of mathematics, we need to understand about sets. Then the logical reasoning. So understanding set theory enhances the logical reasoning skills, and in particular it helps us to become better at the problem solving and proving mathematical proofs. Similarly, the data science and computer science, understanding of topics in data science and computer science requires understanding of sets. In particular, it will help us in understanding data manipulation, algorithms, graph theory and database operations. Thank you, and I am looking forward to the next class.